Yo, what's good, y'all? Link here. And today we're gonna go for another daily LeetCode question. I already got a little spoiler right here. It's gonna be hard with 58% acceptance rate, so you can already tell it's gonna be like an hour video at least. So let's see. Daily 05 dot pi. Oof, I'm already scared about this one. Three numbers. Okay, let's see. Count the number of arrays with k matching adjacent element. Okay. You're given three integers n, m, and k. A good array of size n is defined as follows. Each element array is in the inclusive range of 1 to m. All right. Exactly k indices I. Okay. Wait, what? Okay, so each element has to be within the range of 1 to m. And then we need to have a size of k, satisfying the condition array index I minus 1 is equal to array index I. What? Okay, return the number of good arrays that can be formed. And then we have the module. Okay. Oof, can I get the mod right here already? So it's 10 to the 9 plus 7. All right. So we need an array. So a good array would be an array that has numbers within 1 and m, and then exactly k indices I, where I is within 1 and n, satisfying the condition that array index I minus 1 is equal to array index I. I think looking at the example will be a little easier. Okay, so I got my whiteboard over there. Let's see. So in this case, the answer will be 4. Why 4? So we have a minimum size. It shouldn't be except k indices. Oh, 1. What? Exact k indices I. K is equal to 1 in this case. We need an array of indices. The indices should be, oh wait, actually, the element should be between 1 and 2. The size, what is n for again? Well, a is 1. So I minus 1 is equal to index I. What? Exactly k. Wait, each element. Okay, so let's see. A good array are of size n. Okay, it's defined as follows. Each element in array is in the inclusive range of 1 to n. Oh, I see. We need to have exactly one, exactly k indices, in this case, one indices, one index where this index should be within the range, of course, satisfy the condition that I minus 1 is equal to, okay, oh, I see. Okay, so we need to find the number of arrays of size n where two element of this array must be equal, right? Yes. Okay. And then the numbers has to be within 1 and 2. Okay. Okay. I think, let's see, let's take a screenshot of the example and go to the whiteboard. I would, let's see. Okay, so let's say we have two from 1 to 2. So we have 1, 2. But then we have three element an arrays of size 3. So that means that we need an array of size 3, and we can repeat. Oh wait, last thing that I want to take a look at. Do we need to include all the elements? We don't, right? don't need to include all the elements. We can have repeated element. Okay. We need exactly. Oh, exactly k index, and this is okay. I mean, so in this case, we can repeat one. The thing here is that um would so we have one, one, two, or we have like we can like permutate the thing, right? So we can have two, one, one, okay, and we can have one, two, one. Why can't we have? Oh, it's minus one. Yeah, it's minus one. Okay, so okay. So the idea here is that I think. Okay, so let's see. We have to have a size of three, but we need to have exactly n. Oh wait, k in the indices matching, and the matching index has to be a pair of consecutive numbers, right? So in this case, we have one, one, two. We grab one, two, turn into one element. Oh, we can turn this into one element, right? And make and do kind of like a permutation. We can do one, one, two, and or we can do two, one, one. And then we now deal with the pair of two. So we can do two, two, one. We grab this and put at the end. Now we can have one, two, two. Okay, I think we can go. We can always go from for each element in M. So for each element in M, we want to grab a pair of the element. So for each element of M from 1 to M, the number of permutations, we're going to for each element from 1 to M, we're going to choose that element to be the pair. Also, one thing to notice that if so we always need a pair, right? Just to make sure always need a pair. Okay. So we always have to have a pair. So if n is going to be at least two, right? Nope. N can be from one to. Okay. So if n is equal to one, so if m is equal to one, n is equal to one, then we can return zero mod the module. Because maybe it was zero. Now for each element m, oh actually, okay, so we have another one. If n is equal to one, we return zero, but also if we need to find k pairs. Oh, but we can, let's say this case right here, we have k is equal to two, we can have, oh, okay. Oh my gosh, I see now. If they are together, I mean, in this case, let me take a screenshot of this one as well. In this case, I would think like, oh, so I don't have two pairs, one, one, and one, one. I have to like merge them together, but like I can still do 1, 1, 1, 2. I can still do that. Mm-hmm. Can still do this. Doesn't matter, right? Oh, no, that's right. To like this, because I don't have to return the array, right? Oh, but I need of size 4. Oof. Okay, that's a problem now. Okay. What? What's this? Oh, we don't need to have any. So this in this case we just the parameter. Oh, in this case we can't have any. Interesting. Okay. Oh, interesting. Okay. I don't really know how to approach this problem. Let's see. Um, 1, 1, 2, 1, 1, 2, 2, 1, 2, 2. Okay. Okay. Let's see. I think this case will help me more than the rest. Okay. Uh, the arrays are 1, 1, 1, 2, 1, 1, 2, 2. Okay. How am I going to approach this problem? I'm still thinking if I can do the. Okay, so we go from 1 to 2, and then the current element that we are at the time, that's going to be the pair that we will try to form. Oh, actually, we need 2 pairs, right? Yes. So, oh, in this case, we gotta. Oh, we need 2 pairs. And I was thinking like, okay, so we can just jump to. Hmm, yeah. So if we, case go to 2, we grab 1 and 2, form 2 pairs, and then imitate those, but that won't work because we do have 1, 1, 2, 2, 2, 2, 1, 1. We have those. Well, we can have triple twos and then triple ones. We have 1, 1 in a pair and 2, 2 as a pair, or we can have triple, so 1, 1, 1. Then we'll start with 2. Okay, I have 2, 2, 2, and start with the 1. Huh. Okay. Ooh, okay, okay, okay. I have no idea how I'm gonna do this one. 2, 1, 2, 2. Huh. I'm actually lost on this one. Because, I mean, because the problem that I'm thinking with this approach is like, let's say we have 1, 2, and then 3, and instead of 2, we have like m is equal to 3. I would go for like 1, 2, 2, 3, but I also need 1, 3, right? And what I mean by 1, 3 is like, we can have 1, 1, 3, 3. But then we can, oh my gosh, imagine like k is equal to 1, for example. Oh, then I can't have that. Okay. Uh, this is it's always gonna be pairs. What I'm thinking is okay, so for each number from 1 to m, we need to make, let's see, we're gonna have check all the possible pairs, and then we try let's say, so from 1 to 3, we try 1, 2, and then 1, 2, we have two possibilities, right? So we have a pair of 2, oh sorry, a pair of 1 and a pair of 2, or we can have a triple 1. Okay, so for each element, okay, so for each element, we're gonna try to first make a pair, or we can make a triple. And then we're gonna plus, let's see, actually, this is one option, right? One. And we can have this for each element. So this is gonna be, let's see, so if n is equal to 4, we have 4 possible places to put this guy. So this guy can be, it's gonna be 4 divided by 2. So this guy has 2. Um, oops, I have 5 here. Yeah, I do. There you go. So this guy can go, let's see, either in here or in here, right? So that's gonna be, oops, let's say we have 5 actually. They have 5. Then how many places can we put this guy? So we get 5 divided by 2, 2.5. Do we want 2 or 3? So we can go here, here, here. Oh, here, 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 or here. 4? What? Wait, 1, 2, 3, 4, 5. We have 5 spots to put a 1. Oh wait, one can go right here, it can go right here, it can go right here, or it can go right here. Is that right? Oh. It's actually oh my God. Dude, I hate this like permutation combinatorics question. Let's see. How many options do we have to put 11 here? We can put here, we can put here, we can put here or here. Right. So we have four options. So we have four options to put two elements in here that has to be together. Um, hmm. But now if k is equal to 2, then we need, oof, if k is equal to 2, then we need two elements from here, from M, two elements from M, and then that would, let's say 2, 2, or we can do, oh my God, it's gonna be horrible because we have 1, 1, 1. Oh, we can have 1, 1, 1. Okay. Mm, that would have to be 1, 1. Wait a second. Why can't we have, oh, wait, wait, I think I missed something right here. Why can't we have, in this case, 1, 1, 1, 1? Why this is not a possible answer? No, those are, oh, we have more. Oh, okay, we have more. Yep, okay, we have more. Okay, so, okay, so for each pair, we can do 1, 1 or 1, 1, 1. If k is equal to 2, then we need to do 2, 2. And then, oh, actually, yeah, 2 or 2, 2, 2. That's one pair. Wait, oh, never mind. This is hard. Okay, let me re I like that more. Okay. Okay, so for k is equal to 2, we need two indices. We need two pairs, pretty much. Okay, so we must have 1, 1, 1. This forms two pairs. We can have 1, 1, and then two element add. So this is 2, 2. This forms two pairs as well. Okay, so oof, for m from 1 to 2, for each element, we can have two options. and then this one times what is left. So in this case, this will be 0, so it doesn't have anything. This one will times the number of element that we can put right here. So it's n minus 1 times 1. So this is 1 plus, this case will be what? Oh, wait. Isn't this a pair of 1? And then we recursively call the function with k minus 1, n minus 1. Oh, can we do recursively? And then like maybe cache? Let's see. So we start with n is equal to 4, m is equal to 2, and k is equal to 2. So let's say we for each m, choose an element, and we go to the next. So let's say we chose 1, we're gonna go n. Oh, we have two options. We can either choose 1, 1, right? This give us one pair and go to the next one, or we can go 1, 1, 1. This gives you another pair. This give you two pairs. Yes, two pairs. So we could have 1, 1. In 1, 1, we will go for n is equal to 3, m is equal to 1, because we already used 1, and k is equal to 1. But if we do 1, 1, 1, then we would go for n is equal to 2, m is equal to 1, and then k is equal to, we already used two pairs, 0. So when we get to k is equal to 0, that means that we have all the pairs, and we want to check how many two pairs, and what does that mean here? So we still need to, we have two pairs. Is this right? Oh, this is wrong. This should be, oops. This should be, it should be 1, because we used 3 elements. Okay. So we have this n times m. When k is equal to 0, that means that we used all the pairs. So we multiply those two, because that's pretty much saying that, oh, how many elements is left in case this case is 1, and how many different ways can we use this element and place in the rest of the array is 1. So 1, 1. When we get to 2, okay, so when we will get this part right here, 2, uh, maybe we need to do some combinatorics at the end, right? So that in this case, I'm considering 1, 1, 1, and 2. So okay, when k is equal to 0, we're gonna do n times 1 times what? What if I also add the part where we don't only do 1? So if we only do 1, n is equal to, wait, why n is equal to 3 here? N is the number of elements that are left, so this should be 2. M is equal to 1 because we used 1, and k is equal to 1. And then in this case, we will go for, we would have 2. So we can either make a pair with 2 or with 2, 3 times. But in this case, we would just, oh, we still, yeah, we have 2 elements, M and then 1. But if k is equal to, okay, so in this case, we would have, oof, we can do 2, 2, 2, or 2, 2, 2. Yes. And then with 2, that would just return nothing. With 2, 2, that will work. That will return 1. Okay, I think we can add 3 elements, 3 cases. The case where I just add the element myself, the case where I add two, and then as a pair, and then the case I add three elements of myself, and that's a pair. If so we need the base cases, right? So the base case will be when k is equal to 0, when n is equal to 0. Will we ever get a case where m is equal to yeah, yeah, yeah. Yes. Maybe not k is equal to 0. Maybe we want to do k is equal to 1. So that means that we still need one pair, right? We need one pair. And with that one pair, let's say in this case, I used 1, 1. I still have two elements left on the array. I have one number and I have one pair to be made. So that's going to be, if k is equal to 1, oh, that's going to be a lot of case cases. If k is equal to 1 and n is equal to 2, exactly equal to 2. Okay, so if k is equal to 1, that means that we need one pair. If m is equal to 1, then n has to be equal to 2. Otherwise, we just don't do anything. If k is equal to 1, oh, and m is not equal to 2, let's say we have two elements left here. Oh, actually, no. Actually, no. Because we don't have to use all the elements, right? Let's see this. Oh my gosh. The arrow goes for 1, 2. Okay. We don't have to use all the elements. So this is going to be, if k is equal to 1, then n has to be at least 2, right? So if k is equal to at least 2, okay, so we're gonna return right here. We're not gonna have k is equal to 0. We're gonna do 2, no, 1, the number of m. How many ways can we put one element and make a pair of that? Just one. We have two elements, we're gonna be 2. So let's say we have two elements left. We have 2. Oh my gosh, it's hard, it's hard. Okay, let's say we have 2, 2, for example. I mean, that will be the answer in this case. This will be 2 times 2, which is 4, right? Yes. Oh, it's 2 is m times n divided by, okay, remove the cases where let's say we have 1, 1 and 1, 1 on the other way. Oh, oof. And m, well, let's say we had, okay, so let's say we have 2, 3, 3. So we would have 3 times 3 divided by 3. So that's just 3. Now let's say we need to form one pair, but we have 3 elements. So it's going to be 3 times 1. Maybe it's divided by n. The number of pairs that we still. Oh wait, wait. Oh wait. Oh, that's the base case actually. No, we do need k is equal to 1. If k is equal to 0, because uh, in case in the case we have k is equal to 0, then we just return m times m. Yep. if n is equal to 1 and we okay, yeah. So if k yes, so if k is equal to 1 and we don't have enough n, then we just return 0. Otherwise, in this case, let's say we have like 2. So this will be, we go to the next one. So this will, how many options we have here? So we have, oh my gosh, dude. Okay. Some pure math here. Okay. So let's say we have n is equal to 4, m is equal to 2, a is equal to 2. Oh, actually, I'm using a different one here, right? Okay. So I feel like it's gonna be, if k is equal to 1, we have to have at least 2 n's. And then let's see. Mm, we're gonna do 3 times n divided by 2. That's 3 times 2 divided by 2, which is 3. We have 3 elements, actually 3 possible options to create pairs based on 3 elements. And then for the next recursion, k is minus 1, m minus 1, and then n is equal to 0. And we're gonna have a lot of base case. But I feel like I should go try to recursive this thing. Maybe I can cache somehow. Yeah. Oh, I'm gonna get like a time exceeded this one again. Oh my gosh. So let's try to do that way first, and then we see how that goes. Okay, so recursion, we need n. Let's do so we can differentiate current n, current m, current k, and then let's do base case. Let's do base case. Okay, so if current k is equal to 0, f this has to return an integer. If current k is equal to 0, that means that we don't have we don't have more pairs to allocate. So if so we have n elements left on the array and we have m elements. So we can't, oh wait, what's the only case that we won't be able to form? Because let's say we have 3 elements left and we have 3 elements left on the array. So that's fine because we can just always divide division. But we also, let's say we have 1, 2, and in this case uh, we have 3 spots left on the array, and we have the elements 1, 2, and 3, for example. So we can put 1, 2, and 3, but we can also do like 2, right? So 1, 3, 1, this is valid. 2, 3, 2, this is valid. 3, 1, 3, 3, 2, 3. Oh, I'm missing a couple ones. There's an easier way to do this. So it's 1, 2, 3. and then we permutate this thing, so times 3. Uh, uh, we have three ways of doing this, right? So 1, 3, 2, and then 2, 1, 3. Oh, you can also have 1, 2, 3, 1. Oh my, this is actually oh yeah, this is 3 times. We have 3, 2, 1. Oh my gosh, dude, this is definitely hard. Oh my gosh. Hey, 1, 2, 3. How many options do we have to permutate this thing? So we can have 1 at the front, so we have 2, 3, 3, 2. We can have 2 at the front, so we have 3, 1, and then 1, 3, and we can have 3 at the front, so there's going to be 1, 2, and then 3, 2, 1. This is 1, 2, 3, 4, 5, 6. So this is the number of elements, 3 times minus 1. So 3 times 2. Okay. But when we won't be able to form this, if we need 2 and m is equal to 1, because then we have to put this element right here, right? That's the only case that we won't be able to. Oh my gosh, I forgot one thing. Oh no. Oh no, dude. Oops. Is that we can go back to when I had all the family not. Yep, I lost everything. Okay. Um, ooh. Okay, so I had those 6 options, but we can also have one. So repeat it, right? So 1, 1 at the end. So 2, 1, 3, 1. It can go with 2, 2, 1, 2, 2, 3, 2. Oh my gosh, dude. This is so hard. Um, I'm here for like, oh my gosh, 43 minutes. Let me try to look at some hints. First position, arena 0 has m chance. Yep. That's what I'm doing for from 1 to n. We call it recursion. For each remaining, it's going to be n minus 1. Select k position from left to right and set, wait, what? For each of the remaining n minus 1 indices, from 0 to n, 0 to n, means 0 to n. Select k options from left to right and set array index I is equal to k. For all other indices, that array index I is not equal to array. What? I don't get it. Okay, so for the first element, we have m options. That's right. And then for all the remaining elements, n minus 1, this is this should be like this should be This this is weird because of this. Okay. For each of the n minus 1 minus k position. What? Oh yeah, yeah, yeah. So that k position from left to right and set the array index I is equal to array index I minus 1. And then for all other indices, set a index I is not equal to with n minus 1 choices. Oh my gosh. Yeah. Okay, let's read this guy here. So the problem is pretty tricky and simple. You could find the k indexes, which is a and xi minus 1 is equal to, it's hard to figure out. But how about find out the n minus k, that's k, minus 1. Wait, but k isn't k pairs? Positions where a is because I must be. Okay, I'm gonna pause the recording because I'm already at 46 minutes. I'll read through some comments. I'm gonna try to not look at the solution right now. Try to look at the comment and see if there's any hint that might be helpful. I'll be right back. Okay, so I ended up just looking at the hints, and that actually helped a lot. So this now makes sense. So let's go through the hints again. I had to write on my notebook instead of writing here. So I'm trying to pass what I wrote here into the whiteboard. Okay, so this kind of makes sense because for the first element of the array that we want to form, we do have m choices, right? Let's say m is equal to 2, then we can either choose 1 or 2. And then uh let's try to make the pairs. So in this case, we will have, let's say we choose 1, and let's try to make pairs until we reach k. Let's say k is equal to 2. So we choose 1 to be the first element. We add another one, and k now goes to 1. We add another one, k now goes to 0. Okay, so this is k pairs, which is 2 in this case, right? I was thinking about like, oh, we can't actually do 1, 1, 1, 1, or 1, 1, 1. But this one's is 2. This is actually 4 pairs. So 1, 2, actually, this is actually 3 pairs, sorry. So 1, 2, and 3. So that one won't work. Now for this one, we used let's say we have to form an array of size 4. In this case, we actually use n minus 1 minus k, right? This is what we used. 1 minus 1 is going to be the first element that we chose at the moment, and then k is the elements that we use for the pairs. Okay, so now that we formed the pair that we wanted, now how many elements are left? So we can still put one element right here, right? So this goes to 1 because we use 3 elements. And now we only have one element left. In this case, will be 2. But uh, we can either put 1, 1, 1 in front of the 2 or at the back of the 2, right? So this is actually going to be, let's see, uh, we have, so let's say, okay, so we have n minus 1, oops, minus 1 choices, right? For the rest of the elements, because we already formed the pair at the beginning. And then how many different ways can we put the 1, 1, 1 here? K. Um, and now that okay, because we can either have one in the front of the two, because the case that I use as example, like I have like this. This is the pairs that we have to have together. We have M in the front right here. So let's say M is going to be this first element of the pairs. And here we have the rest of them. So X, oops, uh, Y, and then Z. And then I can put this whole thing either right here, I can put right here, or right here, or right here. So we have one, two, three, four. Mm. Uh, how the heck we M minus one. M minus one right here will be just one. And we definitely don't have one option for when we have one, 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 right? Oh, wait. No, that's right. For all other indices, at the rest to be oh set I array index I is not equal to array index I minus one. Oh, I see. I missed that part. So let's say we have X. Now this one cannot be X. So we have oh wait, that's right. Okay, so we have so this part is N minus one minus K. Yep, which we have right here. But the remaining parts, oh sorry, this is uh this is 1 plus K. Now this rest here is gonna be N minus 1 plus K. There you go. Okay. Hmm. And then for each part right here, we have n minus 1 ways, okay? And then we can have uh let's see. Yeah. So for each of the remaining positions, we're gonna have m minus 1. So let's say we have like 1 here, so we can only have 2 here, right? So it's the number of possible numbers that we can put right here minus the previous one. So we can match this constraint right here. Okay. In this case, we're gonna have 1 position for this, so m minus 1. For each of the k, we have m minus 1. So for the case of, let's use this part, this example here. So, do, oops, go for 1. There you go. Okay, so we have, let's say if we can get to 4. So we start with 1, and then for the 1, we're gonna go 1, 1, boom, that's a pair that we wanted, k. And for the rest of the elements, which is just 1, we're gonna have n minus 1, which is 1 times 1 times 1. So this is gonna be, we have m options for this one. So 2 times we make the pairs, and then for each of the remaining pairs, we have mm, mm. So how many positions do we have here? So we only have one position left, which is 3 minus 1 minus k. This it's 1. So we only have one option right here, right? Hmm. See if that makes sense. Okay. Um. Oh my gosh, what kind of question is that? Okay. So 1, 1, 1. We made a pair. Now we only have one option left. But the problem here is like for all other this which is only one left, we set okay, and RA next I is not equal to RA next okay, with M minus 1 choices for each of the middle positions. Okay, this should be 2, but I don't know how am I going to get 2 in this case. Because we used 1, okay, so we put 1, we added 1, boom, made a pair. Now we only have 1 left. For each one of the remaining positions, we have n minus 1 options. So here we have one option. But how am I going to get the case where it's inverted? Oh, is it or? No, it's not. Because I see how I'm going to get like 1, 1, 2, but I don't see how I'm going to get 2, 1, 1. That's the thing. Or maybe it's actually let me do it something. So we choose 1, so we have m times now the whole thing. Okay. Oh, it's already 2. Okay. So it's going to be we choose the element, made the pairs, made pairs, and then we have m minus 1 times. Let me try to use this. Why is it so small? I don't know. Okay, m times m times n minus 1 minus k. So this will be 2 times 3 minus 1 times 1. For each of the n position, we have m minus 1. In this case, we would have 2 times 2 minus 1 times 3 minus 1 minus 1. This will be, oh my god, 2 times 1 times 1. Oops. Times 1. Why is it into x? times 4 times 4. Just give me 2. Oops. Okay, just give me 2. Um, I think this just gives me 1, 1, 2, 2, 2, 1. Yep. Now I need to permutate this thing. So how I'm gonna permutate? So that's gonna be n minus 2 times a. This gives me what? 1. Okay. Yep. This gives me 1. And so let's see. How many ways can we move those pairs? I think it's gonna be I want to permutate this thing. I hate this math part, man. Holy. Okay, so 1, 1, 2. Okay, so it's gonna be n minus 2 times k, all the pairs, plus 1. Is that right? N minus 2 times k, get rid of the pairs, but we can also put at the end, so plus 1. This will be 3 minus 2 times 1. This is 1 plus 1 plus 1 is equals to 2. And then plus. So this plus this. Let's see if this makes sense. Um, there we go. Oops. Let's see. So m times n minus 1 times plus n minus 2 times k plus 1. Is that what I have for? N minus 2 times k plus 1. N minus 2 times k plus 1. Okay. Yep. I think that's it. Let me see. Uh, there's no way it's just like a formula. Return m times rest is equal to m times n minus 1 times n minus 1 minus k plus n minus 2 times k plus 1. Return rest mod. Dude, there's no way that's it, right? Indentation. I miss. Oh, let's see. Hey, when you got this first one, this one. But 4. Oh, it says second. This is the second one. Okay, let's see if this doesn't work with the formula here. Oops. Okay. So he would have. Let's see. we choose one element, so it can be the one or two, and then we form the pairs. So the pairs will be the first element. Let's make a, let's say F is the first element, and we have K minus 1, and then K minus 2. Okay. For the rest, so this we have three elements. So now if we have two elements left, right? No, that's not right. We have first element, and then second element, second element. And now we have three elements, but we can have at most four. Oh wait, oops. I'm missing one here. K minus 1, K minus 2. Oh, that's right, that's right. That's right, that's right. Let me make this more clear to read. All right, so this is the first element. And then for every K, we're gonna do K minus 1 right here, K minus 2 right here. Now we have two pairs. We have M is equal to 2, and then we have, oh, did I return 4 here? No, I returned 3. Okay, so now I have one element right here, which is, now we have K, N, which is, okay, so now I have, oof, 4 minus 1 minus K, which is 2. Now I have 1 times I minus 1, which is also 1. Oops. Okay, and now I have to permutate this thing. So I did, okay, so that's 2. Now I'm gonna do plus. So how many different ways? Oh, is it? How many times can I permutate this? Okay, so it's, oh my gosh, N minus 2 times K, N minus 2 times K plus 1. So that's, oh, it's 2 times K minus 1. So 2 times N, which is 4, minus 2 times K minus 1, minus 2 plus 1. So that's 4 minus 2 plus 1. That is 3. Hmm. That's 3, and then I have 2 here. Oh, and then I multiply maybe? Kind of like guessing at this point, but oops. K, K minus 1, and then I multiply actually. I doubt it's gonna be it, but okay. I cut this one right, but I got 8. I'm, hmm. I don't think it's multiplying because the adding makes more sense to me than multiplying. No, I got everything wrong. Okay. Where's the hint? Okay. For the first position array in X0, you have m choices, and then for the remaining n minus 1 elements, you have select k positions to form the pair, and then for the rest of the elements, For each position, you have m minus 1. Hmm. Okay, let's try this part again. Oh my God. Okay, so we have, let's see, we have m choices for the first element, and then we need to have for the next k position. So let's say we have k position, so first element, and then we have k minus 1, k, k minus 2, until until k is equal to 0, and then the remaining elements will be uh going to be m minus 1 times uh n minus k minus 1 remaining positions. Oh, is it plus 1? Maybe it's like this, because we can put behind the current pair that we have. Problem here is that I don't see. Okay, okay, so um oh, we need. Okay, let me try this formula. So it's let's see, so m times m times. We have to do k blah, blah, blah. For each of the remaining elements, we have n minus 1 times n times n minus k. Okay, let's see what this one gives me. That's not gonna be the answer, but I'm not sure. Okay, 4. Yeah, that's what I'm saying. Like, I feel like, uh, okay, so this should work, but the problem here is that we won't be able to track when we have. Okay, so let's see. Why did I get 4 here? Because I counted 1, 1, and then 2, 1. I counted 2, 1. Oh, I counted 1, 2, 1, 1. Oh, so, oh, sorry. K is equal to 2 here. I was like, that was not there. I counted, so we have 1, 1, 1, 2, and then I also counted 2, 1, 1, 1, and now let's do with 2. So 2, 2, 2, 1, and then 1, 2, 2, 2. That's 4. Yes. Now the problem here is that I'm not counting when we have just 2 pairs, right? So let's say we have 1, 1. Let's say we have 2, 2. We make this pair. Oh, wait, we can count that, right? Maybe we can do And you can do 2 times k. We have m divided by k. Oops, sorry, no. We have k times 2. This is the total pairs divided by m, which is the options that we have. So in this case, let's say we have k is equal to 2, m is equal to 2. We would have 2 pairs, which is just 1, 1 and 2, 2. And then in here, we do the permutation. So we times, okay, so we times n divided by the number of pairs. So 2 times 2, 2 times k. Nope. We times, how many ways can we do that? So, oh, it's n divided by 2 times k plus 1. Yep. Okay, so that's another part. Let's do, let's see, so rest, this is not rest, it's gonna be continuous pairs. Uh, Continuous pairs. We have the k times k different pairs. Yes, you can say that. So that's gonna be k times 2 k pairs is gonna be k times 2 divided by m. That's not gonna work. Isn't that the opposite? Oh no, no, m. That's right. That's right. And then okay. So what happened if m is equal to 1 and we need two pairs? 2 times 2 is equal to 4 divided by m, which is 1. So we have 1. That's gonna be 4. Eight different pairs. Oh my! And I saw a guy here. In the discussion said that the hint wouldn't work. Yeah, the problem worked for several cases. Yep. Oh, never. Here, this case. Mhm. N minus one k instead of yeah. So yeah, I think that's what I did here. This combinatorics. So n minus one k. That's mm, this is only if that won't work either because you do n minus one. You need to find a way to allocate k elements in different ways. Uh, Let me grab the formula for this permutation right here real quick. Okay, so let's see. We want combination without repetition, right? How this one help us? Well, do we want to have, let's see, how can we fit the pairs? The pair has to be together, right? Yes, they have to be together. So let's say we have like x, x, y, blah, 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 z right here. Pretty much how many ways can we put this pair right here, here, here? But I don't know if that's gonna work. Is it like a math function for factorial? Interesting. I don't have the autocomplete for some reason. Oh my god, this Python LSP is horrible, dude. Math. I don't have it. Uh, import math. Math dot. Okay. Oh, we do have factorial. Okay. So let's see if that works. So n factorial. So rest is equal to math dot factorial of n. No, we want we want what's the k? What? Let's see if that works. Um, n minus one. Oh my gosh, dude. N minus one divided by n minus 8 factorial. So math dot factorial return rest mod. Uh, oops. Let's see. Nope. Maybe it's wait. Oops. I was using the wrong one. I want this one. A factorial. Factorial. Okay. Times this. Okay. Nope. Still not. Okay. That was too much, I think. I'm gonna look at solution. This is not it. It's sort of like, yeah, it's one. What the hell? What is going on? Use fast mod exponentiation to compute this. Use the extended to compute the mod inverse. M times what in the hell times combinatorics of what's this? M times power math the power of n minus 1 to the power, okay. And then mod is equal to this times the combinatorics. Okay, so okay, n minus 1 k. Okay, so oh my gosh, dude, let me look at the again. N factorial. Okay, so this is so we have so n is equal to 4, r is equal to 3. Oof. So how many different ways can we put 4 elements into 3 different spots? But in our case, we want to use, I don't see how this works. So we want to, so we have n minus 1 spots. In this case, we have n, okay, we have n minus 1 spots. So which we fix the first element, right? Okay. And then for the remaining positions, we need to put k elements. But those k elements has to be close to the first one, right? That's why I don't understand why. I think. It's like this one has zero explanation. Don't know. We need to count arrays of length n over 1 to m with exactly k equal adjacent pairs. And the formula is this, for calculating factorial cyberspace. But since we only need one binomial, we can compute and okay, okay, this is pure math. Like, what is going on? Oh, do we have like a math? Oh, we do have. I did not know that. Okay, okay. Oops. Okay. Dude, this one has it has the formula that has like zero explanation. Okay, so uh, we want to find different ways of putting k elements into n minus one spots, which it doesn't make any sense to me because let's say we went here, we already have the first element set. So let's say we have one, right? Let me use the copy this one. So let's say for this one, okay, so let's say we choose the first element to be one, and then for the remaining positions, we want to find different ways of putting into 3 different slots, into 3 different slots, what? K. is equal to 2. So we want to put two elements. But like, oh wait, we want two pairs. Yeah, yeah, yeah. So we can put like 1, 1, or we can have like 1, 1, 1, 1. But like, this is the only right answer, right? Oh, we want to put K. Sorry. So it's K. There's two. Okay. We can have like one, one here. We can have one, one here, and then we can have two right here, two right here. Like, this is the only answer, isn't it? Like 1, 1, 1. How? Okay, so it's probably something with this part. What is m times our? There are m choices for k identical elements if the position for these k elements are fixed. There are m choices. There are m choice for the k identical elements if the position of these k elements are fixed. There are n minus 1 to the power of n times k plus 1 choices for other elements. There are n minus 1 position among the numbers to place k times. There are n minus 1 positions among the numbers to replace k. There are n minus 1 positions among the numbers to place k times. Oh my God. Okay, I'm trying to read through this and try to understand. Pause the video for a second. This whole video is gonna take like 2 hours, so I'll be right back. Okay, I think I finally got it from this part right here. From this solution right here. Oh my God, I'm getting tired about this one. I hate combinatorics, dude. Okay. So the idea, I think it's pretty much what I was talking about before. So we have like the pairs. The pairs has to be uh let's say the pairs like this, let's say 1, 1, 1. And let's say we have x, y, and then z right here. What we want here is to find how many different ways we can place this pair. So right here, right here, right here, or right here. So we basically from all the m, I think, yeah, all the m. No, sorry, all the n different spots. Uh, we kind of like fix one element, which is the element that we want to choose to make the pair, and then that's going to be n minus one. So n minus one, and then we want to find how many ways can we fit those k elements, those k pairs into here. Um, and then for the remaining elements, which is the second part of the combinatorics, so it's going to be n minus k minus 1. We have n minus 1 different positions. Oops. So I think that's the formula right here that we have. So let's see. What if we have 1, 1, 2, 2? So we have n is equal to 4. We fix one element. And then k is equal to 2. Oh yeah, we have two elements. So we can have we still have 1 or 2, and we're trying to put those elements in. Let's see. Okay. So okay, so in this case, let's say we have this example. This is like a valid array that we have to return. So we fix one element. Let's say we fix the one. And it's how many ways can we put two elements in here? Uh, let's see. Mm, So n is equal to 3. How many ways can we have? So we have 3. How many ways can we put an element in here? So we can put it here, 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 or here. And from this part, this is already gonna be the pair. Oh my gosh, dude. I still don't understand how. Oh no, I think that's fine. That's fine. We have one here. And then how many ways can we put two elements? So let's see. Choose k positions out of n minus 1. Choose the first element, so we have m different ways. That's why we multiply by m. Then for the remaining elements, we have m minus 1 to the power of n minus 1 minus k. Oh, okay, that's why. Because with the first one fixed, this is considered to be part of this array of the pairs. So we can put right here. Oops. So in this case, um, I have two elements that we need to put. So we can put like one right here. Oops, sorry. Uh, yeah, yeah, yeah. In this case, oh, okay. So in this case, okay, k is equal to 1 actually in this case, right? No, no. Yeah, yeah, no, it's equal to 2. So how many different ways can we put two elements in the rest of the array? And then the first element is actually part of the pair that we're trying to put, right? Okay. Boom, 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 boom. Yeah, yeah, yeah. Okay. We fixed one element. Okay, so let's see how. So there are two main things that I want to check. So let's say we have n is equal to 4, m is equal to 2, k is equal to 2. So I want to check if we can get this and if we can get this. So if we fix 1, let's say we fix the 1. If we fix the 1, we want to find different ways we can put two elements in here. So we can put here or here, and we just add the 1 to this part. Or we can have this one, and this one. Uh, is it for this case? Are we taking the 2 out, and then we try to put the ones right here, maybe? We choose k position out of the n minus 1. Yeah, so it's kind of like this hint right here. So we fix array index 0, and then that's going to be part of the pairs. And then we're going to try to build each pair with a 2, and then if we add 1, oh, because this one can either become, can it combine to make pair? But this is super hard. Choose k position out of the n minus 1. Uh, okay, k positions to put out the pairs. The n minus 1 is because we fixed one element, make the pair. So if we want two pairs, we want to define different ways to place 1, 1, right? Yes. What if we want three pairs? Let me get rid of this. Let's say we want three pairs. So we do n minus 1, we do n minus 1, so that's 3. So we want to find different ways to put 3 into 3. So that's how many different ways can we put three balls into three different spots? That's gonna be 3, right? So that means that we fix the first element, and we need to find how different ways can we put three elements in here, because one, to form a pair of three, we would have 1, 1, 1. That's three pairs. Yep. And how many different ways can we put those three elements in the rest of the array? So three positions. So how many ways can we put this right here, right? Pretty much, yeah. So this will go here, here, and here, 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 here. Oh, nope. So we can have we have three options, right? We have three options pretty much to put uh these arrays, these elements in the array. And then the last one, it's fixed. So that wouldn't that just, yep, and then to the end of here? Yes, yeah. Okay, I think I got it. I think that's it. But I'm still not 100% sure about this question though. Because we can, let's say, so we can, okay, so we can have 1, 1, 2, 2, 1, 1, 1, 2. So we pick the first element, we pick one element, and then we try to find different ways to, oh, I think in here, I don't, okay, so I understand this part, which is pretty much we get this one, and then we find different ways to put two elements in the rest, which is the two elements of the pair. So right here. So we can have here or here. And then here we just append to the end. But in here, how would you get this part? So we append one, and we have two elements. Would that be here? Two into three. Choose k position out of n minus 1. A for the, hmm, okay. Yeah, I'm still not 100% sure. Okay, this is gonna be like a huge video, but I'm just having like really hard time trying to understand this thing. But hmm. Okay, so I'm wondering, how am I going to get 1, 1, 1, 2 and 1, 1, 2, 2? That's the only part that I don't get it from the formula. Because the formula says this, right? So we find the combinatorics, so we fix one element, And then we're gonna, let's see, we pick k positions out of n-1 where adjacent elements are equal. The rest must be different. Hmm. Oh, I had the opposite in the formula. We have n different object that we want to put into three R spots. In this case, we have n minus one element we need to put into k spots. Oh, I see now. I had the opposite formula. Oh my gosh. It's how many different ways can we put can we choose two k spots to have different elements? Oh, I see. Oh, to have equal elements actually. Oh my gosh, now I see 1, 1, 2, 2, 1, 1, 1, 2. So if we fix the first element, then it's pretty much how many ways can we put into two spots? The how many ways can we choose two spots in the rest of the elements, right? Because this is k is equal to 2. Since we fix one element, that's going to give us two pairs. Two elements is not two pairs. So that's why we fix the first one, and then how many ways can we choose two spots in the rest of the array such that the elements will be equal. So how many ways can we choose k spots within the rest of the array? Because then we can just append the element that we already fixed and then form we can form the rest of the array. And then for the first element that were fixed, we multiply by k. And then for the rest of the elements, it's pretty much how many ways can we put n minus 1 because the previous element has to be different. And that's going to be, wait, okay, so how many ways? Oh, it's going to be, for each one of the remaining spots, we have n to the power n minus 1 elements. Let's see if we can uh, write a formula right here. It's not this one. Okay. Oh my gosh. Okay, so fix one element, find how many different ways can we form groups of k in the remaining array. For the rest, we have n minus 1's options for each remaining spot of the array. Okay, so fixed is equal to m different options for the first element. And then we need to do math.com. How many ways can we put n minus 1, the rest of the array, into k positions? Okay, yeah. Okay, right? So if pairs, so how many ways can we put n minus 1? So how many ways can we choose? So this part is pretty much saying that how many ways can we choose k groups of elements? Yes. How many different ways can we choose k? I don't remember this way of rephrasing the combinatorics formula, but so this is pretty much how many different ways can we grab groups of k inside the remaining of the array, which is n minus 1. Okay, because like in this, let me draw in here. In this case, that would just be, we have 3, so how many ways can we grab groups of 3 of here, right? So this is 3 positions, so right here, um, right here as well. But the problem here is that I don't want to grab like, let's say 1, 2 elements. How many ways can we choose 2 elements, right? So it's gonna be right here or right here. But oh yeah, it's gonna be, yeah, because I was worried about like in the case that we had red, green, and yellow, but we are choosing how many ways can we grab positions of 3. So we are not getting the elements. We want to do continuous array position, right? We want to do continuous array positions. Okay. Oh, okay, so we want to do continuous array positions. So how many different ways can we get groups of k? And then for the remaining position column, that's going to be n minus 1 to the power of n minus k times 1. And just return fixed times, oops, let me do here, fixed my times pairs of com, what? Pairs of times the remaining elements, non bomb com, and then this mod. Oops, I grabbed the whole thing. Okay, not sure what happened here, but I've been getting this error rendering component every time now. Hmm. Okay. Up. Okay. Hmm. Yeah, this part, the pairs. How many different ways can we? How many different ways can we get? This is the part that got me. Like, how many different ways can we form groups of k in the remaining array? That's the part that was hard for me, and I'm still kind of confused about it. Choose k positions out of the n minus 1. Choose the first element. Okay, so choosing the k positions, like if we look at this picture, we want to choose, we're gonna have how many different ways can we choose 3 positions here? Oh, never mind. Wait, let's say we have index 0, 1, 2, 3, 4, and we want to form k is equal to 2, so what do we do? How many ways can we choose 2 positions in here, right? So we can put here and here. Oops. Right? This is one position. We can have those two as well. But the problem here is that we are also considering the fact that we can have 1 and 3. If we choose 1 and 3 and we want two pairs, if we choose 1 and 3 and we consider two pairs, um, then this is not valid, right? Even though we have the first element fixed, as that's why we're doing n minus 1. So let's say I choose 0, 1, 2, 3, 4. I choose position 1 and 3. So let's say 0, 1. I put 1 right here. 2 and 3. I put 1 here. And the rest we have n minus 1. So let's say we can go from 1 to 2. So we would have 2 to, oops, we have to put the last one somewhere. Let's say I put like right here, we have 2, 2. This is not valid, right? Because we need two pairs, at least two pairs, right? Exactly, actually, right, yeah. And this is not valid. I have the pair right here. Oh, never mind. Never mind. I read this wrong. So we're choosing k positions where we can form the pair. So let me go back all the way here. So we're choosing two positions that we can form a pair. No, actually we're choosing k positions. So okay, okay. 1, 2, 3, 4, 5. If we let's say I chose position 2. So I chose position 2 to have 0, 1, 2, to have a 1 here. I've already fixed that one element, so that's one right here. This is one pair. And this is a position where k positions where adjacent elements are equal. So adjacent elements are equal. So we choose one position. And then in this case, we would have like, oh, okay. Yeah, so in this case, we would have where adjacent elements are equal. So that's why we choose one position. And in this case, we would consider right here, and then we'll have one fixed, and so the other one goes here. And that's why we do the part with the remaining. Let's see the remaining here. N minus 1 to the power of n minus k, because n minus 1 because we fixed the first element, minus k because that's the rest of the pair. So in this case, so this is why we have n minus 1. This is why we have uh n minus k. So this is n minus k, this is n minus 1, so n minus 1 minus k. Because when we choose a position, we already consider that that will have a size of k. So the rest of the elements, we can just do the combinatorics of the remaining elements. Okay, I think I got it now. So the fixed part is how many different options can we choose to form the pair. The pair combination is how many different ways can we choose a spot in the remaining of the array, so that starting at that spot we can make a pair. I mean, like a valid group. And then once we choose that specific position for the pair, we have k. So let's see, if k is equal to 3, we need, well, if k is equal to 2, we need two pairs. So we choose an element that of size 2, so k is equal to 2, and we already fixed the first element. So boom, we're gonna have 1, 1, 1, size of 3. And then a subarray of size 3 with all the equal elements, that forms two pairs. Because it's 1, 1, and then 1, 1. Okay, I think that's it. I think I got it. I mean, the explanation now makes sense, but yeah, I'm gonna stop the video right now. I think it's gonna be like 2 hours of video. Yeah, this was a really hard question. It was, there's nothing like programming related. This was pure math, so yeah, I don't know. Okay, thank you guys for watching, and I'll see y'all next time.